So when there is no modifier applied in GD&T control frame, then there will be no relation between these two tolerances. The position tolerance 0.5 mm and the size tolerance plus minus 1 mm will be treated independently. Means the position deviation is regardless of the size deviation. And this is why this condition is called regardless of feature size, RFS. And as per GD&T Rule 2, when no modifier is applied, then regardless of feature size will be applied by default, which we will understand more deeply in next lesson, GD&T Rule 2. So in this drawing, the size tolerance plus minus 1 mm controls the allowable variation in pin diameter. For instance, as the diameter is 20 mm with tolerance plus minus 1 mm, so the pin diameter can range in size from 19 mm LMC to 21 mm MMC. And on the other hand, the position tolerance has specified how much the center line of this pin can deviate from its nominal position. So this 0.5 mm defines a cylindrical tolerance zone that a pin center line must be within, something like this. And the position tolerance zone is fixed no matter what the pin size is, increasing or decreasing. Means if the pin size is produced at MMC 21 mm, allowable position deviation will be 0.5 mm. If the pin is produced at 20.5 mm, the position deviation will still be 0.5 mm. Pin size 20 mm, allowable position deviation 0.5 mm. Pin size 19.5 mm, allowed position deviation 0.5 mm. Pin size at LMC 19 mm, allowable position deviation will remain 0.5 mm. Which seems good and tight, but this creates a significant challenge during inspection, especially with functional gauge, go or no-go gauge. For example, if there are 4 pins on this plate, we cannot simply use a fixed go-no-go gauge to check their position, because it would not account the size variations. Instead, we need a variable size gauge, one that could first adjust the different pin size and then we can see where the position of each pin is. So this makes inspection more complicated and expensive because it required specialized equipment. Basically, a CMM would be needed to ensure that the part meets the positional tolerance across all the possible sizes.